Hi everybody, welcome to another video in Pre-Calculus, section 7.1, application involving right triangle. So in this section, we will solve application involving right triangle. So as a convention, we will say that C will be the right angle, and A and B are acute angles. Opposite to angle A is the sine A, opposite to angle B is sine B, and sine C opposite to angle C. Right. Two important facts about right triangle. First, A squared plus B squared equal to C squared. That is the Beton theorem. And this is pretty much for any triangle. The sum of all the angles add up to 180 degrees, and because C is 90 degrees, so the sum of the two acute angles is 90 degrees. Alright, now let's solve this example. Solve the following right triangle. When we say we solve a triangle, we mean that we will find all the missing lengths and angles of the triangle. Alright, so triangle, I assume that C is 90 degrees, so that's one is given. Now, of course, it could help if we just draw a triangle and write out what we know and what we don't know. Let's just draw a triangle. It doesn't have to be right. I mean, it doesn't have to be with the right measurement and the angle. But this case, once again, C is 90 degrees. Angle A is 35 degrees. And B is 4. So opposite to the sine B is 4. So what we don't have, of course, is the angle B. We don't know. And we do not know sine A. And we do not know sine C. Right. What we do know is angle A, sine B, and C is 90 degrees, which is given. Right. So with this triangle, what we have is, with respect to the 35 degrees angle, what we have, A is going to be opposite to angle A, and B is going to be adjacent, and C is the hypotenuse. And we can use trig function to find it. But first, from this triangle, what we can get is that A plus B plus C is 180 degrees, or A plus B is 90 degrees. I will write C like this, so that will be distinguished with the little c. So in that case, A plus B is 90 degrees. So in this case, we can have angle B is equal to 180 minus angle A and minus angle C. That will give us 55 degrees. Right. 180. Right. Just make sure that we use for right triangle, or pretty much for triangles. So keep it in degrees mode. Right. 180 minus 35 minus 90. Right. 55 degrees. So B is equal to 55 degrees. Right. Next, we need to find A and we need to find C. We do know B though. Now, this is a right triangle, so we just use a right triangle trigonometry. With respect to angle A, we have opposite and adjacent, so that would be tangent. With respect to angle A is equal to opposite over adjacent. Which means tangent of 35 degrees equal to A, opposite, we don't know, over the adjacent is 4. It's easy, right? Cross multiply. A equal to 4 tangent of 35 degrees. Yeah, it is in degree mode. Yeah, so 2.8. Right. Now, so we have A is equal to 2.8. Now, in order to find C, we can use Beton Theorem, right? We know B, we know A, certainly we can find C. So that's one way to do it. The other way to do it is use trigonometry. We have opposite, and then we can find the hypotenuse by set up a different trig identity. But in here, notice that we don't want to use A to calculate C. We're trying to use all the given information to solve for it. We don't want to use the number that we calculate to calculate another one, because this number is rounding off from what we have on the calculator, right? So this is not as exact as the number that is the number that are given here. So preferably we use the number that are given, not the number that we calculated. So we still use B and 35 degrees. So with respect to 35 degrees, we have the adjacent and hypotenuse. So that will be cosine. Cosine of A, cosine of that angle is adjacent over hypotenuse C, which means cosine of 35 degrees is equal to B, which is 4, and over hypotenuse we don't know. Cross multiply. C cosine of 35 degrees is equal to 4. So C, little c, is equal to 4 over cosine of 35 degrees. Divided by cosine of 35 degrees, 4.88. Let's round to 4.9. So C is equal to 4.9. Right. We can check with Beton Theorem. So this is A square plus B square, and when we take the square root of that, we should have 4.88. Yeah. So yeah. So there's more than one way to solve for the missing information, but we prefer to use the given information, not the number that we calculated. Right. So that's the first example. Right, A, B, C. So in this example, we do not know angle A. We do not know angle B. We do know A opposite to angle A is 4, and B opposite to angle B, and C we don't know. Right. Of course, the scale, it doesn't matter. We just draw a triangle just to have the idea what we know and what we don't know. All right. So if we know the size of the legs, we can find C using Beton Theorem. A square plus B square equal to C square. So C square is equal to 2 square plus 4 square. 2 square is 4 and 4 square is 16. 4 and 16 is 20. So taking the square root on both sides, plus or minus square root of 20. But since we're talking about triangle, a measurement cannot be negative. So in this case, we only have square root of 20. Of course, square root of 20, if we write this as square root of 4 times square root of 5, right? 4 times 5 is 20, and then we split the square root. That gives us 2 square root of 5. Right. Of course, we can get the decimal approximation for that, but it's better to skip to square root of 5. Right. Next, we need to find an angle. Let's find angle A first. With respect to angle A, we have the opposite and we have the adjacent with respect to angle A. Of course, we can use C too, but C is the calculated values. I prefer not to use it. A and B would be good enough. So we have tangent of angle A is equal to opposite over adjacent, which is B. So we have tangent of angle A that we don't know the measure. A we do know is 4, and B is 2, which is 2. Of course, A will be tangent inverse of 2. Tangent inverse of 2 is 63.4. Yeah, I just use one decimal place. 63.4 degrees. Of course, in the homework on the test, make sure you round to the correct decimal number. Right. So we have angle A. Of course, if we have A, we have C is 90 degrees. We know A. Subtract from 180, we have angle B. But once again, I prefer not to use that. I prefer not to use what I calculated. So I still want to use A and B here to find angle B. Now, with respect to angle B here, this actually is going to be opposite, and this side is adjacent. So I'll write tangent of angle B is opposite over adjacent. So tangent of angle B is opposite over adjacent. So B is equal to tangent inverse of 1/2. 26.6. Again, I only round to 1 decimal places. Now, of course, we can confirm that A plus B, so this is angle A plus angle B plus angle C is 90 degrees. Indeed, we have 180 degrees, so that check. So we have C is that. And angle A, angle B. Just make sure that once again the calculator is in degree mode, and in our answer, if it is the angle, make sure that's the degree measure. Right, that's good enough. One more. Once again, angle C is 90 degrees, A and B. In this case, we don't know A and we don't know B. We do know C is 17. We do know little a is 8. We don't know little b. Right. Now, first thing we can see here, of course, is the Beton Theorem. Since we know 2 sides, we should know for the right triangle, if we know 2 sides, we should know the last one. So a square plus b square equal to c square. Now we solve for b, so b square is equal to c square minus a square. C square 17 square minus a square. Oops. Yeah, 225, which is 15 square. So b is square root of that. Plus or minus, but we only take positive because in a triangle it must be positive. So 15. So b equal to 15. So this problem we have exact values. Right, so that's what we have. Now we need the angles. Angle A. With respect to angle A, what do we have? We have the opposite and we have the hypotenuse. Of course, we can use B too, but I prefer only use the given numbers. So with respect to angle A, we have opposite and hypotenuse. So that is sine is opposite over hypotenuse. That means angle A opposite is 8 over hypotenuse 17. So we can get a sine inverse of 8 over 17. And that gives us 28.1 degrees. Right, and now of course we can subtract from 180, subtract 90 degrees, subtract angle A, which we know now. We can get B, but I prefer not to use it. Now I'm solving for angle B here. With respect to this angle B, what we do know is this is adjacent, and that of course still hypotenuse. So adjacent hypotenuse, that would be cosine. Adjacent hypotenuse So cosine of B is equal to 8 over 17. Of course, A and B are complementary angles. They add up to 90 degrees. So the function go from the function to the cofunction, right? Remember the cofunction identity. We have a trig function values equal to the cofunction of the complementary angle. So we have that, and so we have B equal to cosine inverse of 8 over 17. We have 61.9 degrees. Of course, when we add these two, they should be 90 degrees because they are complementary angles of each other. Right, so that's simple enough. Once again, in a triangle, in a right triangle, we should be given two information along with the right angle. So we are given information, the right angle, and two other information, and we need to find the missing three other information. It could be sine, it could be angles. Right, so that's what we have. Now, let's go to some application problem. Right, in this example, we have a straight trail leads from the hotel to a scenic overlook, which is here. So we go from here to there. The distance, the elevation from 8,000 to 11,100 feet. So the difference between the elevation of the hotel and the overlook is 3,100 feet. So this is the distance. I mean, not the distance, the difference in altitudes. And then the distance from the hotel, if we walk on the trail, it's a straight trail. So we're not going up and down, we just go straight. Assume that is perfectly straight. That distance is 14,100 feet. The question is, what is the inclination? So they're asking for angle B. So let's draw the triangle again. We'll draw that. This is angle B, and we have 3,100. The difference in altitude feet, and we need to find the angle B. Knowing that the 12 is 14,100 feet. Right, so that's simple enough, right? So with respect to angle B, what we have is hypotenuse is that, and opposite is 3,100. So opposite hypotenuse, what ratio is that? It must be sine, right? So sine angle B is the opposite over hypotenuse. Opposite hypotenuse. Yeah. Oh, we just have 31 over 141. Yeah, just reduce, divide by 100. So in that case, angle B is equal to sine inverse of that. The reason we don't have this or the supplement, usually when we solve for sine, we should have sine inverse and the supplement to that, right? But we don't have to do that because in this is the right triangle. Whatever angle B has to be acute. So whatever answer here should be between 0 and 90 degrees. Sine inverse of 31 divided by 141, and that is 12.7 degrees. Right. So angle B is 12.7 degrees. Right, so that's simple enough. Right, next, let's look at another example. Application problem. Suppose that we have a lighthouse stand that is 100 feet high, stand on the hill that is 300 feet high. So from the sea level to the top of the lighthouse is 400 feet. That's what we have here. And the brochure states that the light from the lighthouse can be seen 20 miles away. So of course the purpose of the lighthouse is so the ship can see the lighthouse, because the lighthouse usually built right next to the shoreline. So when the ships see the lighthouse, they know what the shoreline is about, the distance, where's the shore, where's the land. Right. So, and in this example, we are given that the radius of the Earth is 3,960 miles, and 1 mile, regular mile, is 5,280 feet, and a nautical mile is 6,076 feet. Right, so take all of that information. Now if we look at here, we do have the right triangle here. The furthest distance away that we can see the lighthouse has to be a tangent to the surface of the Earth. By the way, we assume that the lighthouse built perfectly straight. So perfectly straight meaning that goes straight down to the center of the Earth. Right, so this is what we have. Right. So first of all, let's convert that 3,960 miles into feet. So 3,960 miles. The conversion factor 5,280 feet is equal to 1 mile. Cancel out a mile. Multiply those two. 3,960 times 5,280, and we have that much. So 20,90,8800 feet. So that is the radius of the Earth in feet. Right. Now, in this triangle, what we have is, of course, that which will be 20 millions 908 and 800 feet. This, and of course, the distance of that plus the height of the lighthouse. So we have that plus 400 is, so the total distance here is a little more than that. That is 20 millions 909,200 feet. So we need to find the center. By the way, from that sketch, this will be the center of the Earth. And with respect to that, we call the angle theta. So with respect to angle theta, what we have here, this is going to be the hypotenuse and this is adjacent to that angle. That would be opposite. Right. Now the problem here is the surface of the Earth. Assume that to be a spherical surface, even though if the Earth, because the Earth is rotating, it's just like the washing machine. When it's rotating, the stuff try to go outside, right? So in that case, the equator is a little bit bigger than the circle go through the pole, because it's rotating. It will be a little flat on the top, because it tend to fly outside, just like the washing machine does. So the radius at the equator is bigger than the radius go to the pole. Right, but of course we're not even consider that in this example. But my point here is the distance that we see the lighthouse is not a straight distance, but the actual distance from the lighthouse is the curvy distance on the surface of the Earth, or the curvature. The Earth is a spherical surface, so when we talk about the distance, it actually is the arc length from where we're at and to the base of the lighthouse. So when we find the distance from the lighthouse to where we can see the farthest distance where we can see the lighthouse, it is not a straight distance here, but it is actually a curved distance, because the Earth is a spherical surface. So after we find the angle, we will find the arc length. The arc length is equal to the radius times the angle. So we need to find the angle first, and then we can find the arc length. Right. Now, with respect to this angle, we have the hypotenuse and adjacent. So what ratio is that? That is cosine, right? Adjacent over hypotenuse. So in this case, we will take a bunch of different, a bunch of decimal places, because the number may be very small. I will take the ratio. So it's going to be this number divided by that number. So cosine of theta equal to 0.99998088697. Alright, so we can get the angle theta equal to cosine inverse of whatever that is. There are 4 nines. 808697. Alright, so yeah, still in degree mode. Cosine inverse of that, so it is about 0.3544 degrees. 0.3544 degrees. Right, so that is the measure of the central angle. Now we just need to find the arc length. By the way, in this case, if we use that formula, theta is in radian, not degrees. So we convert this to radian. 180 degrees equivalent to pi radian. So cancel the degrees. So we have this times pi divided by 180. So we have that. So that is the measure in radian. in radian. And finally, the arc length. We know the radius of the Earth. Now we use let's use in mile now, because we're going to compare with the number that is claimed in the advertisement, 26 miles. So we compare to that. So we actually use the 3960 mile. For the radius of the Earth times that. Of course, in radian, we can put the unit or not, it doesn't matter. I just don't write that at all. So we just have that number times 3960, the radius of the Earth, and I have 24.49 mile. Right, so the brochure state that it is 26 miles. Clearly that is a little more than the actual values. But having said that, when we are at the distance away, we actually not looking from the surface of the sea, right? Suppose even though this is the Earth's surface, the line out here, of course we not see from the surface. We assume that we are on the boat, and with a little height from the sea level, and from that point we look to the lighthouse. So in that case, yes, this potentially it could be 26 miles, but whatever this stated is a little more than the actual values. By the way, this is the regular mile. If we want the nautical mile, it's even less than that. But the accuracy of this one, it is a little bit overestimate of the actual values. Right, so that's what we have on that one. Right, next we have what we call the bearing. So in navigation or surveying, directional bearing from a point O to a point P is the acute angle. First of all, the bearing is the acute angle from the north-south line. So for example, this P1 here, from the north we go 30 degrees east, so this is the bearing of that point, north 30 degrees east. The bearing of this guy, north 70 degrees west. At this point, of course, we do not go from the north here, because that's more than 90 degrees. We need an acute angle, so we go from the south 50 degrees on the west side. And finally, the bearing of this point is from south, go 20 degrees on the east side. So that is the bearing of point P4. Right, so that's what we have. Now let's look at this example. Boeing 777 aircraft take off from the airport on the runway here. After flying for 1 mile, the pilot, by the way, when we are, okay, let's just read the rest from, I will talk about the assumption later. The pilot of the aircraft requests the permission to turn 90 degrees and head northwest direction. The request granted. After the plane goes 2 miles in that direction, what bearing should the control tower use to locate the aircraft? By the way, now get back to this. Of course, if the airplane, when it take off, it's on different altitude. So I say it go originally, it go up there for the altitude, and then I'm not sure if it is at the highest, but when it turn, assume that will be on the same altitude. But this way, we assume that everything is on 2 dimension. So we just look on the top, on the surface here. So which means we go 1 mile in that direction, and we turn 90 degrees and go for 2 miles. Assume everything is on a flat plane. By the way, what we learn here is plane trigonometry, which is trigonometry on the plane. If we actually want to do the precise navigation, we have to do spherical trigonometry, which I'm not sure. Of course, I'm sure that we do not offer that class here. This is a little more complicated than plane trigonometry on the plane. On the plane, of course, the flat surface. Of course, spherical trigonometry is a bit more complicated. Because if we study about navigation, we definitely need to know that. Right. So, what is the question? What bearing should the control tower use to locate the aircraft? So, meaning that we will need to find this angle here, and then north, that angle on the west side. Right. So, how do we do that? Now I will draw this again. I think this is close enough. Right. So regionally the bearing is 20 degrees northeast. So this is east side, that is west side. Originally it is 20 degrees. And the question is, what will be the new bearing? Right, we do know that the plane turned 90 degrees. The measurement here is 1 and that is 2. Right, so this is angle O, P and Q. Right, so look like we need to use angle O. So angle O is the whole thing. So angle O equal to theta plus 20 degrees. That sounds like 0, but this is angle O. Yeah, if it is confusing, just put a hat on it. So that is the angle O. Right. So with respect to angle O, we have here is adjacent, and that is opposite, and we don't know the hypotenuse. Right, opposite, adjacent, that is tangent, right? So tangent of the angle O is equal to opposite over adjacent. Opposite is 2, adjacent is 1. So tangent angle O is equal to 2. With that, the angle O is equal to tangent inverse of 2. Tangent inverse of 2, 63.43 something. And then we subtract 20 degrees to get theta. So from here we have theta is equal to angle O subtract 20 degrees. So the angle theta is equal to that subtract 20 degrees, which give us 43.4 degrees. So that subtract 20, right? And so the bearing will be north. We go 43.4 degrees on the west side. So that is the new bearing of the plane. Right. So with that, I stop section 7.1 here. As always, thank you for watching and see you in another video in Precalculus.